Hello, hello, hello. Minions, greetings.
Milk's here.
And the MoNaCos.
We are present and accounted for.
Are you?
Ooh.
Can you hear me now?
I know. Turn off the music.
Page 21 in your packet.
Video number 8.
We're going to learn what a titration is. So you're getting the foundation for your rite of passage in this unit.
This is it. This is the big lab.
And we want to know what is the purpose of titrations and how do they work. What is it, what's its purpose, and how does it work?
We're really going to manipulate that neutralization reaction we just used.
Right.
So we can use that neutralization reaction to find the concentration of any unknown acid or base in table T.
MAVA. MAVA.
Yep. MAVA equals MBVB.
The definitions in table T show you that Ma means the molarity of the acid, Va means the volume of the acid.
And then the B is the base, so molarity of base, volume of base.
It's an equality because we're going to neutralize things so that they're in equal concentrations at pH 7. And in doing so, we're going to be able to figure out what the concentration of either the acid or the base, depending what we don't know, is.
There you go.
So
it's a little algebra.
Bra.
And you'll have 3 of the 4 variables.
Yep.
So the neutralization reaction we learned about in the last video is the reaction ends up being very predictable.
What is it that they make?
A salt and a water.
From an acid and a base.
Correct.
Got
and
it.
the pH is 7.
Neutral.
Allowing us to obtain the last of the variables that we don't have, we actually have to do this piece to get that third variable.
Right, so what you'll actually do in lab is you'll have a beaker of unknown concentrated acid.
Yep, but you'll know the volume of it.
And you'll know how much you used. And you'll have a burette or a tool filled with a known concentration of base.
And then you're going to titrate.
You're going to add the base to the acid until it neutralizes.
And that's when you check about what the volume of base you added was.
And so you
get
take,
there.
And then you figure
Now you got 3 of the 4.
variables.
So let's check it out a little bit
You will
further.
see.
We usually use phenolphthalein
As the indicator. Yep.
Yep.
And the endpoint for that is about 8 or 9 pH units. So it's a good neutralization. It's passed truly, but it's good enough for our purposes.
Correct.
There are a bunch of other indicators. Maybe you could suggest one that gets you closer to actual pH 7 if you know your jams.
We'll see.
You might be able to
figure something out during that lab, the
Right.
precip lab. Right.
Yeah.
All right, so the generic procedure for all titrations.
We will know 3 of the 4 variables. How many times we got to repeat that? Moving on. You're going to know them.
First, molarity of the base is given to us. We're going to put the base in the burette.
BB, base in the burette. The burette is this long pipette with little gradations and graduations on it and a valve at the bottom.
That's what this picture is.
Yeah, B-U-R-E-T, not B-I-U-R-E-T, like in living environment. It's burette.
Yep, burette. Yep. Then we are going to measure out a predetermined amount of acid, let's say 10 milliliters.
That's a good amount to use.
Because 10's a nice number.
Right.
Right? And I'm going to add my little bit of
It's
indicator
nice
to
to
it.
use math with because we have to do some math at the very end. So you want to pick volumes that make your math easy.
Seriously.
Right. Don't make it harder than it's got to be.
And then you're going to titrate it with the base, which means, as you see in the middle blue picture B,
Drip, drip,
you see the
drip, drip,
drippies?
drip, drip, drip.
And then you're going to do that until the color changes.
Right, and that's how you know it's neutralized because the pH changes and the indicator changes color when the pH changes. So you've known that you hit a certain pH spot because your indicator says ding, 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 ding.
Right.
You made it.
And you can see from the picture at the top, I have initial volume reading of the base. When
Final
I'm done, I
volume.
have a final volume. Now I can figure out how much base I used.
Had I added, if I started at 0 and I ended at 50, I must have used 50.
Right.
There you go.
Right. You might start at 50 and end at 0, though. And then it's simply plug and chug.
Chug,
A little algebra.
bro.
Okay.
Yeah.
So the results.
It's a controlled acid-base neutralization. Controlled in so much that we can stop at a very specific pH point. An uncontrolled acid-base neutralization is like when you add vinegar to baking soda and you get the volcano. You don't stop at any particular point. You just blast through it. It's fun.
It's so much more fun than it's uncontrolled.
But this is fun because you're watching for the really pretty color changes.
Oh.
So you can get some really awesome, vibrant color changes depending on the indicators you use and the
Uh-huh.
pHs that you're trying to stop
Yeah,
at.
yeah.
It's really cool.
Right. Just do us a favor. Don't get too frustrated if you got to do an extra time or two till you get really good at hitting that endpoint.
You have to do it a few times in order to get a result that's
Seriously.
averaged. Otherwise,
if you get that deep pink the first time or two, we get it.
yeah, we'll see that in a pre-lab video. But
Yeah.
moving on.
We'll get it.
So, an example problem. I'll scribe, you talk.
Okay. Cool. Very good. All right, so again, MAVA equals MBVB. Example problem, I have a molarity of the base is 1.5. Volume of the acid, 10 mils. Volume of the base, 22 milliliters after our titration.
Right?
Mr. MoNaCo, it is time to plug.
Well, the first thing I need to know, I should not use that color. No. Don't use that color. I can't really see it well. Go with blue.
Blue it is.
Because I'm trying to figure out the volume of the...
All right, are you going to rewrite your equation to help you or something maybe?
I'm going to write one more thing here.
Oh, MA.
equals unknown. It's X or question mark.
Okay.
So I'm going to rewrite my equation. MAVA equals MBVB.
Very good.
Then I'm going to plug what I've got. There we go. MA is unknown.
So you're going to put an X for that?
I like to put an X.
I like to put an MA.
It don't matter, really.
It really doesn't matter.
I'll use MA just because for you.
Oh, okay.
MA times VA. Well, my volume of the acid that I used was
10 mils. And now I'm going to multiply it by the molarity of the base
1.5 capital M
times the volume of the base,
22.
22 mils, milliliters. So I can see, basically, to get the MA by itself, I need to divide by 10 on both
Right.
sides. So you can combine that top piece if you like to first. That's cool.
I do have my calculator on me.
Oh, look at you, handy dandy.
So 1.5 times 22.
1.5 times 22 equals
33.
33, divided by 10 to get MA by itself.
Let me show the steps here.
Yeah, do that.
Molarity times milliliters,
Yep.
technically the units, but they'll fall out at the end. And then we have MA times 10 ml.
Dividing both sides by his 10 mils to get it to cancel. Well, algebra,
Mils cancel.
mils cancels, and I get in my calculator now 33 divided by 10 equals the molarity of the acid, MA.
And I got 3.3 capital M because that's the only unit left over. Right
Yep.
there.
And that's the only reason why I like to put the MA in there, so I know my unit matches up with what I'm looking for. And guess what? MA equals 3.3 molar.
Yeah, maybe it's just straight algebra.
Straight algebra.
All right.
There's a bunch of plug and chug problems that we got to work on.
And you're going to do it 3 times in the lab, at least.
Yes, for each titration.
Yeah.
So there
Maybe
it is.
more if you screw it up.
So now you need to know how to use the titration equation to find the concentration of any unknown acid or base. That's going to be the one variable you don't know.
Right.
Ready?
See?
Done.